Good afternoon, students. Welcome you to Mathematics 5. This is our presentation, exam-based presentation for April, May, and August, as well as November examination for 2020. I want you to pay attention as we are going through some of the content that you might be familiar with or you might not be familiar with. Welcome all to Mathematics 5. I wish you to be hardworking students as you are, and I want you to watch this presentation carefully, and in case you have any question, please you must contact me. I am your tutor, Ms. Loide Shikongo, and I will be your tutor for Mathematics 5. And I'm quite fleetly, but I want you to do your part as well. Do not just come to me with a question from number 1 up to the end. You must try so that I can know where you understand and where you don't understand. Okay, let's go through. We are going to start with calculations with numbers. Mathematics 5 is having a lot of chapters. We are having 5 chapters in Mathematics 5, and then Mathematics 6 we are having from 5 up to 12. Okay, we are not going to do a lot and everything, but I'm going to touch those critical parts that I find quite challenging. Okay, we are going to start with the ratios. When you are talking about the ratios, this is a comparison of quantities of the same kind or of the same unit. When you're talking about ratios, your units must be the same. If they are not the same, then we know that we have to convert to the same unit so that we can either simplify or work through ratios according to the question. You should know how to simplify ratios. You should know how to divide or share quantities in a given ratio. You must know how to increase and decrease quantities in a given ratio. And you also need to know how to calculate a quantity if the ratio is given and if the other quantity is also known. I'm just going to go through one example in each. Okay, we are having this simplifying 20 minutes to 1 hour. 20 minutes to 1 hour. So then when we're presenting our numbers in ratios, we use this. Okay, now you can see that this is simplifying and our units are different. Whenever units are different, you have to convert them to the same unit. Now, critically speaking, minutes to hours. If you convert from minutes, 20 minutes to this hour, will give us decimals. And sometimes working with decimals, you need to do something else. So then we'll rather convert hours to minutes. And then we know that in 1 hour we have 60 minutes. Now that means we'll be having 20 minutes to 60 minutes. And then once the units are the same, we don't write our ratios with units. We cancel out the units and then you just simplify the 2. Okay, 2 goes in 6. I know that will give us 3. 1, 2, 3. That will be the answer there. This is not the only thing in simplifying ratios. You need to know how to work with different units. You might be asked to convert from kilometers and meters, seconds and minutes, cents and Namibian dollars, for instance, liters and kiloliters, square kilometers and square meters, cubic units and liters. It depends on what you are having, and it's up to the ball will be in your hands now to know that you know how to simplify and you know how to convert from from one unit to the other unit. Okay, let's move on to dividing or share quantities in a given ratio. Now, I have an example. A mother shared 30 sweets among her 2 kids in the ratio 2:3. How many sweets the elder one received? So then we are having a total. Of 30 sweets to be shared between the 2 people in the ratio 2:3. Now we are having the ratio 2:3, and the question is now asking us to work out how much the older person will get. Of course, 2 is smaller than 3. Obviously, this 2 is for the smaller kid, and then the 3 is for the older one. So then the question is asking to work out how many sweets this person will get. Now, ratios, when it comes to sharing a total between a certain ratio, we have 2 methods of doing that, but they are all rooted from one thing. You need to add to get the total ratio. How much is total that the person is having to be divided? So then the first thing, we have to add the ratios together. 2 plus 3 will give us 5. Now, 2, the one with 2 out of a 5, how many will get? So then you take 2 out of 5, then you multiply it with 30 to get this person. And then the other one is now 3 out of 5 times 30. Then you work out how many sweets the older one will get. But when coming to the questions now, the question asks you to work out how many sweets the elder one gets. So then there's no need for you, even in the examination, to provide that information because it's useless. That is not the question. So then go straight to the question and answer the question. So then it will be 3 for the older one out of a total of 5. Then you multiply it with the amount of to be shared. And please give your answers with correct units. If you just write 5, now 5 what? So then I prefer you to write 5 sweets depending on the answer, the question. 5 sweets, 5 cakes, 5 what? Give your answer with correct units. The other method you can still use with the ratios. After we add the ratios together, we can take the amount to be shared, that will be 30, then we divide it with 5. 30 divided by 5 will give us 6. Then we multiply it with each ratio, we multiply it with this quantity. Like the older one will now get 3 times 6. That means we get 18 sweets. Okay, so then that is it. So you should know how to divide quantities in a given ratio. Okay, the other one will be increasing and decreasing quantities in the ratio, in a given ratio. How do we increase and how do we decrease quantity if the ratio is given? Alright, the first question is increase $100 in the ratio 4:5. Now you have this $100. You want to go up with that ratio 4:5. When it comes to increasing or decreasing ratios, you need to know the trick. When you are increasing a quantity in a certain ratio, we write our ratio as a fraction. How is it going to be written as a fraction? It depends now on whether you are increasing or you are decreasing. If you are increasing, then your ratio should be written as an improper fraction. I hope you know what an improper fraction is. The numerator should be bigger than the denominator. So then this ratio, we write it as an improper fraction, and then you multiply it with the amount to be increased. So then to be 5/4 times 100. If you were decreasing, then you have to write this ratio as a proper fraction. To be 4/5 times $100. Then you get your answer. So then increasing improper fraction, decreasing proper fraction. Alright. Then the second question is the value of a car that cost $120,000 depreciated in the ratio 1:2. Calculate the new value. So then we have that keyword depreciate. to depreciate is just to decrease. So then that question is just asking you to decrease that $120,000 in the ratio 1 to 2. As I said earlier on, if you are decreasing, write your fraction as a proper fraction. 1 to 2 will be 1/2, and then you multiply it with the amount to be decreased, which will be 120,000. Then you get your answer. So then it will be a half times 120,000. That will probably which is 60,000. So then the new value of the car, it's 50,000. Okay, increasing improper fraction, decreasing proper fraction. Alright, then we come to the next part, which is calculating a quantity given the ratio and another quantity. Now in this case we are given two information, but there's something which is missing. The example is there are apples, sorry for that spelling, apples and oranges in a bowl of fruits in the ratio 4 to 5. If there are 50 apples, how many oranges are there in the bowl? So then we are having that the two quantities we are talking about are apples and oranges. First come, first solved in ratio. So then we're having apples to oranges. Now you are given that the ratio is 4 to 5. 4 in that ratio is for the first quantity mentioned in the statement. So then 4 is for the apples and 5 is for the oranges. Now you are given that there are 50 apples. This side I'm having apples. I have to put 50 under apples because it represents apples. So then how many oranges are there? So then usually in mathematics we represent an unknown with x or any letter of the choice, but we are mostly used to x. Okay, then you work out. So then if you have a ratio like this, you can either cross multiply, get your x. X times 4 is 4x, which is equal to 50 times 5. Then you divide both sides by 4. Then x will be equal to this. Then you get how many oranges are there. That is one way of doing it. You can cross multiply. You can also work out the missing here. Which number did you multiply with 4 to give us 50? Which number was multiplied by 4 to give us 50? So then if you find out maybe that it's 5 or 7, then you do the same here, because these numbers were either increased or decreased with the same quantity. Okay, so then when you come to the ratios, in most cases you should not confuse when to add the ratios together and when you cross multiply, or you should know how to work with those ratio questions. The questions might be quite at another level, but then the key point is always there. There's always something clicking that here I have to add the ratios together, and here I'm given the ratio and the quantities. And I always like saying that whenever you are working in mathematics, do not wait until you finish the whole statement so that you can put something down. The moment you start reading the question, put something on paper already so that you can focus your thinking much better. I hope you find it easy and you manage when it comes to the ratios. Okay. The next thing that I want us to look at is limits of accuracy. Now I put this one here because most of the students, they don't know how to work with these limits of accuracy. We are talking about upper and lower bounds. Limits of accuracy has to do with what was the number before it was rounded off. If I have a number like 70, it might be 70 on its own, but it might that also this number was another number. Maybe it's a rounded off number. Now you have to look at which numbers can round to 60, to 70, for example. Let's look at it in the same thing, in the example that will come up. Now, a set of numbers the first is included in the list, which is called the lower bound, and the last is excluded in the set, called the upper bound. Okay, let's look at that. The distance between Okahanja and Windhoek is 60 kilometers to the nearest 10 kilometers. So that it's not 60 on specifically 60. It can be 60 maybe, or maybe it can be 59. Maybe the kilometers are 59 kilometers there. It's only that this number was rounded off to give 60. Okay, now find a set of possible outcomes. That is, what was the number before it was rounded off, and state the lower and the upper bounds. Now, if you are talking about 60 kilometers in limits, and we are talking about which number, how was the number before it became 60? If you take maybe 50, will 50 round to 60? Not at all. If you take 51, will 51 round to 60? No. How about 52? Not at all. 53? Not at all. 54? Not at all. 55? Can 55 round to 60? Of course, yes. Because if you round it, it is said to the nearest 10 kilometers. Now, if you're talking about rounding to the nearest 10, 5 represent the unit, and then this is a 10. We are rounding of 5, this one, and then 5 can round of 5, it will become 6, and this number becomes, so then it can be. But if you look at 4, 4 cannot round off 5, so then it remains, it will be 50. If you have to round it off, it's not 60. Okay, so then the first number is 55. If you take 56, of course it can round, because 6 can round 5 to 6, becoming 60. 57, 58, 59, 60, 61, 62, 63, 64, 65. Let's look at 65. If you look at all these numbers, they can round up to 60. 8 can round 8, 5 becoming 60 here. 4 cannot round 6, so then 6 remains 6, but then this one becomes, but then when you come here, 65, 5 can round 6, and then 6 will become 7, so then this one becomes 70, which is out now. We want to see numbers that can round to 60. So then when you come to the numbers that can round to 60, it's only 55, 56, 57, 8, 9, 10, 61, 62, 63, 64. These are the only numbers. Now, which one is the upper and which one is the lower bound? Now, according to our statement about what lower and number bound is, the first number is included in the list. The first number that can round 6 to 60 is 55. So you can call 55 the lower bound. And the last number is excluded in the set, which is called the upper bound. 65 is now our upper bound. It's excluded, it's not part of the list that round to 60. So then 65 is the upper bound and 55 is the lower bound for that. But then in the examination, when you come to questions on limits, you don't need to get all these numbers, make a list of all these numbers so that you can find your lower and the upper bound. There's always a shortcut for that. Like in this case, if I want to find the upper and the lower bound, I'll take the number after the word to the nearest what now? To the nearest 10 according to the question. I take that number 10 and I always divide it by 2. 10 divided by 2 gives us 5. Now to get the lower bound, you minus. You take this 60 minus 5, it will give us 55. So then this is the lower bound. And to get the upper bound, you add 60 plus 5, which will give us 65. So then our upper and the lower bound will be like that. Now there are students that always either add 5 or minus 5, but they don't know why we have to add 5 or why we have to subtract 5. Okay, so then from there you should know. You always take the number after the statement to the nearest what? to the nearest unit. You know it's only one unit there, so then you take 1 divided by 2 always, then you find that number that you either subtract or add to. You get your upper and the lower bounds. Okay, I have some questions, numbers that I want us to round off. To write as upper and lower bounds. Find the lower and upper bounds of these numbers. The first one is 200 and 2,200 centimeters to the nearest 100 centimeters. So this number was rounded off to the nearest 100 centimeters. So then as I say, take that number that was how it was rounded off, then you always divide it by 2. So then it will be 100 divided by 2, then it will give us 50. To get the lower bound, it will be 2,200 plus or minus 50 to get the lower bound. Then you get your answer. And then to get the upper bound, you add 2,200 plus 50. Then you get your upper bound. Okay, the next one is 57 meters to the nearest meter. How many meters are there? There's only 1 meter. So then it will be 1 divided by 2, which will give us 0.5. To get the lower bound, subtract 57 minus 0.5. To get the upper bound, add 57 plus 0.5. Then you get your answer. The next one is, we have 2.63 correct to 3 significant figures. Then when it comes to significant figures, you don't take 3 because there's a 3 there, then you divide it by 2. Not at all. You come to your numbers. Now, which one is a third significant? 2 is the first significant. 6 is the second significant. And 3 is the third significant. You underline that and then you put a 1 under. Then other numbers, you just put 0. There's a comma here, and then there's under other numbers, you just put zeros. Then to show you this number, which should be divided by 2. So then in this case, 3 significant figures, it will be 0.01 divided by 2. The answer that you get here is the one that you add or subtract to get your upper and your lower bounds. So then we come to significance. You check which one represents that significant, underline it, put 1 under, and put zeros under the other number. If there's a comma, make sure that you put a comma there. Okay, then you read that number, you divide it by 2 so that you know which number you add or subtract to get your bounds. We have another example, another number, 1,300 correct to 2 significant figures. We are still talking about significant figures. Do not take 2 divided by 2. No, come to your number. Which one is the second significant? I know 1 is my first, 3 is the second significant. So then I underline 3, put 1 under, and put zeros under other numbers. Okay, if you read this number, which number is that? Of course, it's 100. So then that is 100 divided by 2, which will give us 50. You either add or subtract to get your upper and your lower bounds. We continue. We have 11.8 correct to 1 decimal place. Again, for this number, it's rounded to 1 decimal place. Do not take 1 divided by 2. When it comes to first decimals, you still have to do the same with the significant. Which one is the first decimal? Is 8. You underline it, you put 1 under, there's a comma, you put a comma here as well, and 0 on the other side. Oh, it's fine. This is just 0.1. Okay, so then it will be 0.1 divided by 2, then you get that number. You add and subtract to get your upper and the lower bounds. And then we are having 4.65 correct to 2 decimal places. Still, which number represents the second decimal? 4 is a whole number, 6 is the first decimal, 5 is the second decimal. So you underline 5, you put 1 under, 0 here, there's a comma here, you put a comma there, and then a 0 on the other side. So then you can read this number that it's 0.01. So then this is the number that you have to divide always by 2, and the answer that you get here, you add it or subtract it to get your upper and the lower bounds. I hope you will not make mistakes when it comes to working with limits. In case you have a question, I'm always available. We are continuing with the limits, but then we are moving on to the calculations involving limits. Sometimes we'll be given 20 divided by 4, and the question will ask now to find the upper and the lower bounds of this number. How does it work? If you are adding to get the lower bounds, you have to work out the lower bounds of each number. You will always be given how the numbers were rounded off. Let me say you have 20 divided by 4, and these numbers were to the nearest whole number. For example, whole number, we know it's a 1 divided by 2, 0.5. To get the lower bound of 20, you know we have to minus. 20 minus 0.5, it will give us 19.5. And then 20 plus 0.5 to give us 20.5. That is upper and lower bounds. And 4 minus 0.5, it will give us 3.5. And 4 plus 0.5, it will give us 4.5. Now, you don't just work these numbers. You have to find the upper and the lower bound of each number first before you answer the question. Now, if it was addition now, to get the lower bounds, you add the lower bounds together. And to get the upper bounds, you add the upper bounds together. So then imagine it was now 20 plus 4. To get the lower bound, you take this lower bound, which is 19.5, then you add this lower bound, 3.5, then you get your answer for that. And then for upper bound, you take the upper bound of that number, 20.5, then you add to the upper bound of the other number, 4.5, then you get your answer. Okay? And then when it comes to multiplication work the same as addition. If you're multiplying here, you do the same. Find the lower and the upper bound of each number, and then to get the upper bounds now of the calculation, you multiply the upper bounds. And then for upper bounds, for lower bounds, you multiply the lower bounds, and then you multiply the upper bounds for multiplication of the upper bounds. Okay, and then when it comes to subtraction now, subtraction and division, they are also having the same way how to do it. Like if we're adding or subtracting here, we say we cross. When I know that this is subtraction or division, I don't write my numbers like that. I write them in a row so that I will know I have to cross out. It's a cross. For you to get the upper bound, you take the upper bound of the bigger number, then you minus the lower bound of the smaller number. You take the upper bound of the bigger number, and you minus the lower bound of the smaller number. Like in this case, it will be like that. So then I like writing my numbers like 20. It's 20.5 and 19.5 for the lower bound and 20.5 for the upper bound. And 4, I write them like this. It's 3.5 for the lower bound and 4.5 for the upper bound. Then from there, I cross. To get the upper bound, I take this one minus that, 3.5. And then to get the lower bound, I take this minus that. And this is the same for division as well. Okay, so then you must know. And then the key questions in the examination will always now like calculate the minimum or the smallest or the maximum or the largest area or perimeter. And we know that when we talk about area, we multiply. So then follow the rules of multiplication. lower bounds together, upper bounds together. Perimeter is addition. We add the borders together. Upper bounds together, lower bounds together. The question may ask to work out the greatest speed. You know that when you calculate speed, you divide distance divided by time. This is already a division, so then you must follow this rule on division. And then distance. How do we work out distance? Speed is equal to distance divided by time. Distance is equal to speed times time. It's a multiplication, so then you have to follow the rules on multiplication of the bounds. When it's time is distance divided by speed. So then you also do that. You follow that rule of division. So then when you come to this type of questions, you should know the rules, how to work with the calculation, how do we add limits, how do we multiply, and so on. And you must also be careful, like if the question asks you to work out the minimum, obviously that is already the lower bound. The maximum, obviously that is already the upper bound. So then just answer the question. Do not put a lot of calculations there. Just go straight and answer the question. All right. We are moving on. The next thing that we are going to look at is algebra. Algebra is complex, so to say. It's a backbone of mathematics. Most of the questions that most of the chapters that normally comes after algebra, they will ask you to go back to algebra once and again. So then there are a lot of things that algebra is evolved in mathematics. Algebra is a set of letters and numbers connected by addition, subtraction, multiplication, and division. I hope this one we know. We are having a correction of numbers and letters now. How do we work with numbers and letters together? Now in algebra, it's divided in between expressions and equations, and also inequalities. I put equations and inequalities together because they almost work the same. An algebraic expression has no equal sign. And in algebraic expressions, we simplify. When you simplify, you either add, subtract, divide, multiply, including the polynomials. We factorize by common factor. We factorize by grouping. We factorize by difference between two squares, and we also do factorize by quadratic trinomials. My dear students, you need to know how to factorize each expression very well. And algebraic fractions as well, it's under algebraic expressions, where you need to add, subtract, multiply, and divide. And you should also know all the methods of factorizing and how to apply them, because algebraic fractions also sometimes they will take you back to factorizing so that you can simplify those expressions. And also under expressions, we are also having transpose formulas, whereby we have to make something the subject, a certain letter a subject of the formula. And under equations and inequalities, an equation has an equal sign, while an inequality shows a relationship. When you talk about the relationship between the sides, then you can either say equal to, greater than, less than, greater than or equal, and so on. And then in algebraic equation, we do solve linear equations and also simultaneous equations. And you should know how to, especially simultaneous equations. We solve quadratic equations. In solving quadratic equation, we can either do it by factorizing, by completing the square, or by using the quadratic formula. And we also have solving linear inequalities, and we also present them on the number line. When it comes to inequalities, you should know how to solve those linear inequalities and present the result on the number line, or write down an inequality from the number line. Okay, let's look at some of the examples now. I put them together. We'll do factorize completely. How can we factorize that one? Now we are having 7ac plus 14a. As I said, when it comes to factorizing, you must know which method we are using. We have 4, taking out the common factor, so then you have to look at the expression. Am I going to take out the common factor? Am I going to difference between two squares. Is it quadratic trinomial or what? Grouping. So then you should know which one is that. For this one, it's a taking out the common factor, whereby 7a is the common factor. The highest number that can divide 7 and 14 is 7. And the highest number that can divide AC and A is A. So then our highest common factor is 7a. What do we do with the highest common factor? We divide it with all the terms. 7 goes in 7, 1, A goes in A, 1, so then we're only left with C there. Plus 7 goes in 14 two times, A goes in A, 1. So then the answer will be 7A and then C minus 2. Now to check if your answer is correct, factorizing is an opposite of removing the brackets. So then you should know, if you remove the brackets, and we know how to remove the brackets, multiply the term outside with all the terms inside. 7a times c, of course it will give us 7ac, and then 7a times 2, of course it will give us 14a. If it will give us that, that means our factorizing is correct. And you should also check in your brackets whether it's fully simplified. C plus a cannot be simplified further, so then that one will give us that. And the other one is we have 9b squared minus 121c squared. How are we going to factorize this? Are we having the common factor? Can 9 divide 121? I don't think so. B squared, c squared, we don't have a common letter even here. Can it be factorized by grouping? Grouping, you must have 4 terms minimum. And then can you factorize it by quadratic trinomials? Quadratic trinomials, you must have 3 terms. It's a must. And then difference between two squares, you must have the numbers which are square numbers. If you look at your numbers, they must be square numbers, and the indices of your the letters must be even. So then quadratic difference between two squares can work here. How do we do it? We square the square numbers and we divide the indices by 2. You simplify those indices. The square root of 9 is 3. B, 2 divided by 2, it just give us b, power 1. So then to give us 3b there, minus the square root of 121 is 11, and then c, 2 divided by 2 just give us 1, of which will just give us c. Now 3b minus 3 is 11c is the answer from this. But then how do we write it? We write it twice with different signs. So then it will be 3b minus 11c and 3b plus 11c for that. If you remove this, you can already see that if you take 3b times 3b, it will give us already 9b squared. If you take these last terms, it will already give us 121c squared. Do you understand? Okay, I know this is not how we remove the brackets, but if you try to remove the brackets correct, it will take you back to that. Just go and try it at home. Then the next one, we are having 8t squared minus 4a plus 2t squared minus 8. How do we factorize this one? Check if you are having the common factor. 8t squared, 4a, 2t squared, we don't have a common factor there. Not at all. A is not, t is not here, a is not here, none of the letters here. So then we have 8 here, we have 2, we have 4 here, there's nothing here, it's only 1. We don't have the common factors of numbers, we don't have common factors of letters. So then we cannot factorize by common factor, but we can factorize it by grouping. We know 80, these two terms are having something in common, and these two terms are having something in common. So then we can factorize by grouping. You take out the common factor for this, which is a, then in bracket we have t squared minus 4. That will be the answer for that. And for this one, the common factor is 2, and then inside the brackets we have t squared minus 4. when it comes to factorizing by grouping, make sure that your terms, your brackets will be having the same answer. Then you take it out as a common factor. So then finally, this one will give us t squared minus 4 together, and the terms outside, you also, there's a plus here, you also put them together. So then it will be a plus 2 together. Again, if you work out these brackets nicely, it will take you to this. It will take you to that, the one that you were given initially. Okay, so then you must know which method, which factorizing method you are going to use. Alright students, then we can move on to simplifying. We are having ax plus ay divided by px plus our minus py plus qx minus qy. How can we factorize this? How can we simplify this? Firstly, you have to check whether your expressions can be factorized. Like in this one, we have a common factor a, and then x plus y. And then this one we can factorize by grouping. We have a common factor of p, and then x minus y. And then for this one also, we are having a common factor of q. It's a minus. Then we have a common factor of q, and then x minus y. Then from there, then you can check whether you are having a common factor, so that you can cancel out those common brackets. Unfortunately, we don't have a common factor. This is x plus y, x minus y, x minus y. If there was a minus here, then we have to cancel out one of the brackets and then simplify the other one. So then when it comes to simplifying, you have to just check whether there's something that can be simplified, and then you simplify, factorize. Then you factorize them first. You can cancel out the common brackets, and then you can continue simplifying your expression. We are having also 6 over a plus 2 multiplied by a squared minus 4 over 3. If you look at this 6a plus 2, if you look at this expression, this can be factorized. This is a difference between two squares. So then you can factorize it first. It can be 6 over a plus 2 times a minus 2 and then a plus 2. If you factorize this one, this is what you get, over 3. Then you can cancel out the common brackets. A plus 2 and a plus 2. This I can cancel. And remember, you can only cancel up and down, top and bottom. And then once you simplify, check also if your numbers can be simplified. Of course, 6 and 3 can be simplified. 3 goes in 6 is 2 times. Then you write down your answer. What is left? It's only 2 multiplying this one. So then it's just 2 and then a minus 2 over, there it's only 1, which will just give us that a, and then 2 and then a minus 2. Then we can quickly move on to the next one. We have 2 over x squared minus 1 minus x over x squared minus 2x plus 1. How can we simplify this one? This is subtraction of algebraic expressions. And then how do we the way we subtract fractions is just the same way we subtract other things. So then you have to make sure that your denominators are the same when it comes to subtracting fractions. And then again, before you move on, make sure that see if you can factorize. 2. This can be factorized. This is difference between two squares. This one is a square number, this is a minus, and the power is even. So then it will be x minus 1 and then x plus 2 for this. Minus x, and then this one can be factorized as well. It's quadratic trinomial. The factor is 1. We take factors of 1, which is only 1 and 1. Then if c is positive, then all the terms will be having the same sign, which is negative and negative. So then the answer here will be x minus 1 and x minus 1. Now we can check from this one. We can now see which one is to find the highest common factor. Now x minus 1 and x minus 1 is the same. So then we can take this as a common factor, and then this one is a common factor. Then from there you apply the rules of adding or subtracting common fractions. Okay, we are not going to do everything from this one because time is really going and we have a lot to cover. I want us to move on to making the letter the subject of the formula, transposing equations. Making when it comes to making a letter the subject of the formula, it's just the same way you are solving equations. You transfer you move your terms the same way you move your terms when you are solving equations. So then in this case you want to make y the subject. You want y alone on the left hand side. How can you make y alone? So then I always say start with the term which is independent. It doesn't depend on other, especially it doesn't depend on the subject that you want to make. Like in this case, -4 is dependent. It's not attached to 2y. It's a separate term on its own. You can see terms are already separated by a minus. So then you can move that 4y on the other, -4 on the other side. And remember, when you move terms, you always change the sign. So then it will be x plus 4 in this side, and then we're having 2y. You want y alone. How can you get rid of these two? Division and multiplication goes together, so then you can divide both sides by 2, and so y is equal to x plus 4 divided by 2 as a subject of the formula for that. I want us to look at the next one, B, which is t is equal to SR over 100, and make R the subject of the formula. If you're having fractions, we always make the other number, a whole number on the other side, a fraction, and then we cross multiply. So then we move t times 100, it would be t100 or 100t, 100t, which is equal to SR. SR times 1 is just SR. So I want to make R the subject. I get rid of S by dividing. So then R is equal to 100t divided by S. What if I take D to be the subject? P is equal to A plus BS squared over K. Okay, I want to make S the subject, this one here. How can I make S the subject of the formula? I can move A first of all on the other side. So then it will be P minus A, which is equal to BS squared over K. And then once it comes here, you have in mind a fraction here. We can make this one a fraction as well. Then we can cross multiply. That will be K, and then P minus A is equal to BS squared. I put this in brackets because everything P minus A is being multiplied by K. Okay, not just K times that. Put it in brackets. Now I want S. Remember that. I can get rid of B. Divide both sides by B, and then cancel out. I'm only left with S this side. Can I put it here? S is equal to S squared is equal to K, and then P minus A over B. Then I want S, but there's a square here. How do I get rid of the square? Is by applying the square root. The square and the square root cancel out, so then S will be equal to that as a subject of the formula. So then you should know how to move or write between how to move your terms, what to do when you're having a square, what to do when you're having a square root, addition, fractions, and so on. And your guide is having quite a lot of exercises that you can practice, and find yourself stuck, please consider me. I want us to move on to solving equations and inequalities. We are having a lot of things here. Solving equations and inequalities. We are going to start with solving the simultaneous equations by elimination and by substitution. The first one we can take is 2 2x minus y is equal to 3, and 2x plus 3y is equal to 23. We are just going to do 1 for this because of the time. So elimination will eliminate one of the variable. You always check your numbers, which one can be eliminated, and then you always look at how the numbers, your terms are. It's easy to eliminate the x terms because if I take 2x minus 2x, of course this one will just give me a 0, leaving me with only the y terms to work on. Negative 1 minus 3, it will give us negative 1 minus 3, it will give us negative 4y is equal to 3 minus 23, it will give us negative 20. Then from there we can work out the y. Divide both sides by negative 4. This cancel out, so then we know that 4 goes in 20 is 5 times y is equal to 5 for this. That is elimination. Once you find your y, you can now substitute it in any of those equations, whether it's the first or the second one. You can take 2x minus y is equal to 3. Now you know that your y is 5. So then when there's a 5, a y, you put 5 because you know the value. So it will be tx minus 5 equals to 3. Then from there, you solve for x. The same way we solve linear equations. Then you solve for x and then you find the value of x. I want us to move on to the second question, which said solve the following quadratic equations by factorizing, completing the square, and by using the quadratic formula. We are also just going to look at the first one. Okay. We are having x squared plus 5x is equal to 6. The question said factorize. And then we know how to factorize this. This is quadratic trinomial. So then how do we factorize this? I can move 6 on this side. So then x plus 5x. Move the constant term on this side. It's a positive minus 6. Then equal to 0 because there will be nothing on this side. And in most cases, our quadratic equations are equal to 0. Okay, then you factorize this one. How do we factorize? You look at for factors of 6, 1 and 6, 2 and 3. Then if 6 is negative, you look at the middle term, more positives. Your bigger number will be positive and the smaller number will be negative. And then from there, you choose a term that will give us 5 when you add them together. Which term? It's only negative 1 plus 6 that will give us 5x. So then that will be your answer now. You put them in brackets, x minus 1 and then x plus 6 is equal to 0. You factorized it. Then the question said solve that equation. You did not solve, so then after you factorize it, you equalize it to 0. X minus 1 is equal to 0 and then x plus 6 is equal to 0. So then you can now say x is equal to, if you take 1 on that side, it will be 1. X is equal to 1. And then here, if you take 6 on that other side, x is equal to negative 6. So then these are the two solutions. And mostly quadratic equations are always having 2 solutions because of this power. X is having 2 solutions. So then this is it when it comes to factorizing. And when it comes to completing the squares, we are having x squared plus 5x is equal to 6. Completing the squares has to do with dividing the middle term, which is a b divided by 2, and then you square it. Then you add it on both sides of the equation. X squared plus 5x plus, this is b. You make 5 over 2 and then you square it is equal to 6 plus 5 over 2 and then you square it as well. Okay, completing the square. Then you take your calculator. When after you work out this part, you end up having x plus 5 over 2 and then square. And this one answer here 6, I think this one will give us, it will give us 12.25 if I'm not mistaken. Okay, then from there now, to get x, x plus 5 over 2 squared, you get rid of this square by taking the square root on that side. So then it will be x plus 5 over 2, which is equal to the square root of either positive or negative 12.25. Then to get x, you move that on that other side with a positive root, and you also move on that other side with a negative root. So then x is equal to now the square root of a positive 12.25 plus 5 over 2, or x is equal to negative, negative the square root of 12.25 plus 5 over 2 as well. Then you get your answer. Okay, so then by using the quadratic formula, it's a matter of knowing the formula for the quadratic. The formula for the quadratic is x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Then if you look at that expression, x squared plus 5x is equal to 6. Then you make this one here to be x squared plus 5x minus 6 is equal to 0. Now, which one is your A, which one is your B, which one is your C? A is here because the quadratic equation takes the form of a x squared plus bx minus c, or plus c, depending on what you are having. These signs can differ depending whether the terms are positive or negative. So then this is A, the coefficient of x squared, and b is the coefficient of x, and c is the constant term. It's a matter of substituting your numbers into that quadratic formula. Where there's a, so then a here we are going to have 1 because there's a 1 here. A here it's a 1. C it's going to be negative 6. This is negative 6. Be careful of your signs. B is 5. So then it's just a matter of substituting and work out step by step until you get your final answer. Oof. That there? Then we move on to solving inequalities and showing them on the number line. We are having negative 2x less than 1 equal to 11. Solving an inequality is the same as solving an equation. It's just that you have to keep your sign. Don't make it an equal sign. It's a relationship sign. And then we are also having, like, if you are either dividing or multiplying with a negative number, then that inequality sign must also reverse. If it was facing that side, it must face this side. So then we can do that. We can move 1 on that side. We're left with negative 2x. What is this? Is less than 11 plus 1 will give us 12. Okay, if you take that one on that other side, it will give us 12 because it's a positive. To give us 11, it's a minus. It's a positive number here. It will give us 11 minus 1. So then we divide both sides by negative 2. The moment we divide with negative, then this sign must also reverse. So then that is the only point that I want you to know when it comes to negative numbers. Okay. Then we come to the logarithms. Logarithms is another way of writing indices. Okay, so then we are having the index form and the logarithmic form, as you can see it there. In index form, you can read it 2 to the power of 3 is equal to 8, and then logarithm we read it as log 8 to the base of 2 is equal to 3. You must know how to switch between writing numbers in logarithmic form and also writing them in an index notation form. So then the first question is, write these following numbers in logarithmic form. If I'm having 3 squared is equal to 9, how can I write that as a logarithmic form? In logarithm, the index, you should know that this is an answer. This is the base which remains the same. We normally just switch the two. So then it will be log base 3, 9 is equal to 2. The base remains the base, and then these two, we normally just switch them. 2 is the answer. The logarithm is just asking which power will give us 9. Which power is raised to the base of 3 to give us 9. So then it's always 3, it's just 3 power 2 that will give us 9 for that. Okay, then in the logarithm form, you must know how to write those logarithms in the index notation form. For example, if I'm having log of 5 to the base of 1, log 1 to the base of 5 is equal to 0. What does it mean? How can you write this in an index notation form? Remember, this is a base, it will be 5. Power 0 is equal to 1. Remember, we only switch these two. This remains the base, 0 is the power, and then 1 is the answer for that. So then you should know how to switch them. Now we're having logarithmic laws that you need to know. We're having a product law. Product law, if you're having, you are adding two logs, it's the same as you are multiplying them. If you are subtracting the two logs, it's the same as you are dividing them. And the power law, multiply the power with the log. The power becomes the number that you are multiplying with the log that you are given. Let's move on to using the logarithm laws. We use the laws to separate and also to write logs as single logs. We are only going to look at one example for each. Let's look at C, where it said log 3x squared. How can you separate? Because this is one log, and you have to use your laws. And then if you look at this log, it means log 3 times x squared, because we know there's a multiplication there between 3 and x squared. So multiplication, how do we deal with multiplication of logs? You should know that multiplication was, how was a multiplication? A product law, it was once addition. So then this means log 3 plus log x squared. If you are to separate these two, it's a multiplication, and multiplication was rooted from addition. You add the two logs. And again, we are having this power law. The power law said what? Let the power multiply the log. So then finally, this log is going to be written as log 3 plus 2 log x. So then if you separate them, if you want to make them log, so then this is what you have. So then you either write them separate, or you simplify them, write them as a single log. Let's look at writing them as a single log. Let's look at the other example. Let's take b. We have 2 log b minus 3 log a minus 4 log c plus 2. How can you write this as just a single logarithm with just one logarithm? We don't want to see these lots of logs. One thing you must notice is this, number 2. You have to write it as a log as well. And there we are having examples of logs. Which logs can give us 2 as the answer? It's only log 100 that give us 2 as the answer. So then I can write this as a log as well. So then to be 2 log b minus 3 log 2 minus 4 log 3 c plus log 100. Then from there, now you use your laws. Now myself, I prefer working with addition first, this one, and then I come with. But then if you look at this still, this one was once power laws. So then I can write 2 log b as log b power 2 minus log 2 power 3 minus log c power 4 plus log 100 now. Then from there I use my laws now. Addition, and then you subtract. Subtraction was once a division. Okay, you know this is subtraction, and when I was subtracting, you know it was once a division. So then I can start with this. That will be log c power 4. A plus was once a multiplication, so then I can write log 100 c power 4. I mean c power 4, and then over, this is a minus, b squared, and then times 2 power 3 for that. So then it's a single log. It will be now log 100 c power 4 over b squared 2 power 3, or maybe 2 power 3 b squared, to make it, if you are to write it according to algebraic rules, number in front of the letter. Okay, we are not going to, if you find something that you can try this one by yourself, if you get stuck, get to me. Then again, we can use the logarithms now to solve exponential equations. We are not going to do everything. We are just going to look at the first and the last one. If you're having 3x power x is equal to 9. In most cases, usually when we are solving exponential equations, where your index, the unknown, is the power, then you can either use the indices or you can use the logarithm. When using the indices, you have to write this base numbers with the same base. I know 3 can be written as a base of as a power of 3. 3 power x is equal to 3 power 3. And once the bases are the same, you can cancel them out, and then we know x is equal to 3 for that. But sometimes, what if maybe 3 power x is equal to 8? Whereby 8 cannot be written as a power of 3. That is where logarithms comes in. So then you have to log everything. It can be log 3 power x is equal to log 9. Let's keep it at the 9 there, log 9. Then from there, you use the power law for this. It will be x log 3 is equal to log 9. Then I want x, I divide both sides by log 3. Log 3, this cancel out, then you get your answer for that. Of which, of course, it will be giving us 3. So then x is equal to 3 for that. Okay, let's look at the last one. 2 log x plus log 3 is equal to log 5x plus 2. Again, we are solving for that x. How can you use logarithm to solve for that x? Okay, for if you are having this, use your powers, use your terms, and use your laws as well, so that you can have only one log on one side equal to one log on the other side. So then this one here, this is addition, which was once a multiplication, and this one can be written as a power log. So then this one can be log x squared plus log 3 is equal to log 5x plus 2 for that. And then you can now use your logs. Addition was once a multiplication, so then this is the same as we have log 3 times x squared, which is equal to log 5x plus 2. Now in logarithms as well, there's a rule that if you're having log a m equal to log a n, if the bases of the logs are the same, then m is equal to n. So then same apply here. I know if the bases are not given, I know there's base 10. If the bases are the same for the two sides, then we can cancel them out. Then we can write 3x, that would be 3x squared is equal to 5x plus 2. Then from there you solve this equation. We can already see that this is a quadratic equation because the power is 2. Then you can solve that equation now using that quadratic method, either factorizing it or completing the square, or maybe using the quadratic formula. If you have a question on when it comes to logarithms, please contact me. Otherwise, we are done for this session. Practice and practice more often. Consider revising questions that usually carry a lot of marks. because that is where you need to score. Know all the steps, the rules, and the formulas. As we come to the logs, know the rules, know the laws, formulas, know all the key questions, what to do when you are solving, simplifying, proving, etc. And read instruction carefully, answer the questions straightforward, and then write neatly and you can also please manage your time. I see some blanks. I don't know whether the student is done, was the time up or what. Finally, you are always welcome to ask me in case you have any question. I wish you all the best in your study. Thank you very much.